Hello, class. This is our 2-7 notes that I'm just getting set up here, and they are all about square roots today. So if we are finding a square root of a number, we are trying to figure out the number that multiplies by itself to get that value. So the first thing I want to do is just look at an actual number example. So if I am finding, say, the square root of 81, then I would have to think what multiplies by itself to make 81. So since 9 times 9 equals 81, or 9 squared equals 81, the square root would be equal to 9. So we are looking at the opposite of squared, or I guess really inverse is a better word in math, right? It's the inverse of something that's being squared. So it's the inverse of squared. And what we're asking ourselves is what number times itself equals the value under the root. Okay, so we have this idea that it's the inverse of squared. So that goes back to every operation that we have in math has an inverse. So if we're adding, the inverse is subtraction. If we're multiplying, the inverse is dividing. So if we have a square root of a number, that is the inverse of squaring something. So instead of taking 9 and squaring it and getting 81, if we take a square root of 81, that brings us back to the 9. So the next row of problems is just some pretty easy square roots that we might know. So sometimes I have to think what times itself. So 5 times 5 makes 25. This is just like me thinking down here. You don't have to write that down. Since 5 times 5 makes 25, my square root is 5. On the next one, the plus or minus in front just means I'm going to write a plus or minus in front of my answer. And you might know that 8 times 8 makes 64. So my square root of 64 is 8. Be really careful. A common mistake is for students to just think that taking a square root is dividing a number in half, and those are not equivalent. So on this last one, the 900 seems like a really big number. I know that 3 times 3 is 9. And so it makes sense that 30 times 30 would be 900. So because of the minus sign in front of the root, this is going to be a negative 30. So just remember, if I have like a negative number, I can't take a square root. And that's because in order to get a negative, I have to have positive times negative. And that's not going to be the same number times itself. But because this minus sign is outside, I just bring it down. So when we talk about perfect squares, we're talking about numbers like 2 squared, which is 4, 3 squared, which is 9, 4 squared, 16, 5 squared, 25, 6 squared, 36. So we're talking about those perfect square numbers that are a number times itself, the product of a number times itself. So the definition for a perfect square is the square of an integer. So if if I can take a number and square it, that number becomes a perfect square. So the square of an integer. So for the next couple problems, we're looking at approximating. And this is sometimes tricky. So it can help to have a list of these perfect square numbers in front of us. So I think I'm going to erase my ... and I'm just going to write in the rest of them. So let's see, 7 squared would be 49. 8 squared, 64, 81, 100, 121. So 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. What the heck, we'll write one more, 144. That's kind of off the edge of my paper there. So I've got all those perfect square numbers. And then for my first problem here, I'm looking at approximating the square root of 103. I'm going to rewrite this problem over here so I can see it and my list of numbers at the same time. So I have to ask myself, if I'm approximating this, which two numbers is it between? Well, 103 is between 100 and 121. So in my head, I'm going to think, well, 100 is less than 103, which is less than 121. And so I'm going to make all the square roots. So square root of 100 is less than square root of 103 is less than 121. The square root of 100 is a 10. So 10 is less than the square root of 103 is less than 11. So that means my square root of 103 is going to be pretty close to one of these, right? It's going to be between 10 and 11. And then we kind of want to think, which one do we think it's closer to? Is it closer to the 10 or closer to the 11? And 103 is closer to 100 than it is 121. It's only 3 away from 100. It's like, I don't know, 18 away from 121. So if we had to approximate it, we would say it's approximately 10. And some of my students are really bothered by saying 10. So they will add like a decimal place and they'll say, well, maybe it's 10.2 or maybe it's 10.3. And then sometimes they'll even check their accuracy to see how accurate they are in estimating. And that's fine. I don't care. All I want is something that's closer to 10, not an 11. So if you just leave it as 10, that is just fine. If you want to take that extra step and maybe try approximating a decimal, good for you. So square root of 47. So 47 is between the 36 and the 39. So I'm going to say square root of 36 is less than the square root of 47, which is less than the square root of 49. And then I'm going to take those roots. And then again, I want to think which one is the square root of 47 closer to? Well, 47 is closer to 49. So I would say that the square root of 47 is approximately equal to 7. But then again, some of my students, that really bothers them because it's not really 7, it's a little bit less than that. So if you want to say like it's 6.8 or 6.9 or something instead, or 6.7, that's fine. But what we're looking for is just the number that it's closest to. Last one is ordering least to greatest, and we've been working on these and talking about these for a while, but this one's got some more square roots on it than what we're used to seeing. So I'm still going to draw my number line and do the easy numbers first. It's always my strategy. I'm going to number them with pencil. I don't know how far I need to go. I can always, maybe I'll go to -4 and +4 just in case. I can see like a square root of 9 here. I already know what that one's going to be. So I'm going to label them in pencil for my original number line, and then I'm going to go back with a marker and add in these other values. So -2.5, super easy. I'm going to mark that one first. That one's going to be halfway between 2 and 3. And then the next easiest one looks to be the square root of 9. Square root of 9 is just a 3. So over here where my 3 is, I'm going to mark square root of 9. And then I got some tricky ones. So let's do 4/3. Most of us are getting pretty comfortable with fractions like that. So if I have 4/3, 4 divided by 3 is 1, and I have 1 left over. So 1 and 1/3. So I would mark that one a little bit closer to the 2 or to the 1 than the 2, right? It's between 1 and 2. So 1 and 1/3. I might even try to make it a third of the way between them. I'll mark that one 4/3. Let's see, that one's done. And then we have 2 more square roots, the negative square root of 5 and the square root of 13. So if I think about my perfect square numbers, the negative square root of 5, I'm already thinking ahead, is close to negative square root of 4. So negative square root of 4 would be equal to -2. So negative square root of 5 is going to be really close to that, but maybe a little bit to the left. So if here is my -2, it's going to be a little bit to the left. Oh, I already have a 2.5 here. And so I'm going to guess because 5 is really close to 4, it's going to be in between that -2.5 and the 2. So there's going to be my -√5. And I might check that in a minute with the calculator just in case I'm curious. Last one is square root of 13. So square root of 13 is going to be a bit less than, square root of 16, which is 4. So that's going to be a little bit less than 4. So I'm going to put that one in over here. All right, so now I've got my numbers in order. All I have to do is kind of go left to right here. So I'm going to move this up. And then I have a -2.5 as my answer. And then a negative square root of 5, 4/3, square root of 9, and square root of 13. So there are my 5 numbers in order. This is the end of the 2-7 notes. Make sure if you have questions that you ask them.